Hello, my name is Tony Petrosian, and I'm a program manager with database systems here at Microsoft. And today, Tobias Turnstrom is also joining me for this session. He's also a PM with the database systems. And today we're going to focus on Azure SQL Database and talk about performance and scale for SQL DB.
Yeah, I'm also Tony's humble servant, so I'll try to make sure that we actually see some of what's going on.
All right, so he's here to do the demos. That's the truth of it. So we'll start with the Azure services. You can see that the platform offers a variety of services. And today in the data section, you'll see there's a little SQL database. And so that's the focus of our conversation. And hopefully you've already watched the introduction to Azure SQL Database session. So we're not going to go over all of that again. So we're going to just dive into the performance-related issues. So on the performance and scale, the current version of Azure SQL Database is our version 12. This has been in production since March, and we're very proud of Azure SQL DB, and the performance for Azure SQL DB is really awesome. With premium databases, you get SSD I/O, really low latency, and you have a variety of options. We really have improved the ability to manage large databases, and we provide you a lot of insight into your database. So let's take a look at some of the concepts in performance. So first of all, we have this notion of a database performance throughput, which is the DTU. This is a relative figure which establishes the relative performance of Azure SQL databases to one another. So going from 5 DTU to 500 DTU, you can assume that the performance of a 500 DTU database will be 100 times more than a 5 DTU database. And the way to really think about it is a DTU is this bounding box of resources that you get for your database. For a relational database to work, you need some memory, you need some CPU, you need to be able to read from the disk, and you need to be able to write. And the amount of resources that you get with each database is defined by the DTU. You want to add anything to that?
Well, you could just say it's the horsepower of the database.
That's a good way of going. For people who are really interested in the cars, the DTU is the horsepower measure of your database. Tobias likes cars. So for our singleton databases, when you go and create a database in Azure SQL DB, you have the option of creating a basic database. That's at the low end of the spectrum. A basic database comes with 5 DTU, and it's $5 a month. Pretty reasonable price for that. And then you have the standard databases and premium databases. And our premium databases range from P1 to P11, P11 being the largest database that we offer today. We've added a couple of things here. We added the P4 recently with 500 DTU. And the nice thing about Azure SQL Database and this whole concept of scaling is that you can go from a basic database to a P11 database. You can upgrade and downgrade by simply choosing the level in a portal or by REST APIs or PowerShell. And the operation of upgrading and downgrading the scale is completely online. So you can continue to use your database. The workload continues to run while we're upgrading or downgrading your database. So it gives you a nice opportunity to start small, and when the load goes up, you can upgrade your databases without taking any downtime. So just to give you an idea of how big a P11 database is, you can assume that all of this stuff runs in Azure. So a nice big DS machine in an Azure VM with lots of CPU memory and I/O is what a P11 runs on. We also have this concept of an elastic pool. So for an elastic pool, the idea here is you might have a lot of databases because, say, you're a SaaS vendor, and lots of databases that have different performance profiles at different points in time. It's not that every customer wakes up at 8 o'clock in the morning, does exactly the same thing as every other customer. So you have some databases that are cold, some databases that are hot, some databases that spike at different times. And you need to be able to burst at different times. The pool allows you to basically take all your databases and put them in a single resource pool. And these databases can share the resources. And then you can optimize your workload based on the aggregate resource utilization of your databases, while at the same time allowing a single database to burst. Now, the nice thing about this is that you can manage the pool with policies, how big the pool is and so on, but at the same time, also manage the databases within the pool with policies. So each database can have a minimum amount of DTU, which is guaranteed, and you can set a maximum spike level for the database, so the database can't spike beyond that. So this is the concept of the pool. And at this point, I think maybe it'll be good to do some demonstrations and take a look at some of the work we're doing and with performance and how you can go up and down. So just to make it very clear, when you come to Azure SQL DB, you can create a pool. Pool can have different sizes, and then you can move databases to the pool. You can also move databases out of the pool, and we have different pool configurations. You can have basic pool, standard pool, and premium pool for folks who need databases that can burst higher or not so much if you're using a basic pool. So Tobias is going to show us some cool work on how the performance stuff works.
Cool. Yeah. So let's get to some actual real stuff here instead of this talking. But I did like your talking. It was very beautiful. So I'm here in the Azure portal, and we have two databases. One is I call my lazy database, and one I call my busy database. And I also have one of these elastic pools already created. And the difference between the lazy database and the busy database is basically that I run a heavier workload against the busy database than I do against the lazy database.
Okay. And
it's been running for a while now. You can take a quick look. So these two command prompts I have here just show the two workloads. So you see the one that says simple OLTP. All it does is it runs a couple of reads and writes against the database and keeps doing that in an infinite loop. And this one, the upper one, runs against LazyDB, and the lower one runs against BusyDB. And it runs OLTP, also runs this reporting workload, which is basically more of a range type of query.
So it puts a lot more stress on the database because you got transactions going on, you got queries going on at the same time. Database is going to be busier.
Exactly. So if we go back to the portal and just click on LazyDB, we can see here that this one is an S0, which is the lowest tier of the standard databases. And it means it has 10 DTUs.
Right.
So whatever CPU read, write, and so on that a 10 DTU database has, that's what it can do.
So what happens when you put too much load on an S0 database? Does it throttle? What happens to the workload?
Well, what happens to your laptop if you do too much workload on your laptop?
It just slows down.
So that's the same happens here.
All right.
So we can go and look at BusyDB as well. And you can see BusyDB is also running an S0 database. And here you see that I also plotted the chart of the actual resources that are being used. And you can see that he runs at, or it might be a she, but it runs at 100% CPU right now.
All right, so the busy database is an S0 database, and you're doing queries against it, you're doing transactions against it. Clearly, at CPU running at 100%, the users are not going to have a great experience.
Correct.
So what can you do to improve the user experience in this?
Well, first we can take a look at that you can actually query and see these metrics directly from T-SQL as well. So I just opened...
So this is the SQL Management Studio.
This is SQL Server Management Studio, right? And we have this DMV, Dynamic Management View, called DMDB Resource Stats that's available in each database. And it basically returns the percentage used of CPU, read, write, and memory for this database for the last hour.
I see.
So here I am in BusyDB. If I execute this, you can see BusyDB is at 99% right now. And let's just do a top one here so we don't get ourselves confused later. That happens a lot when I bring Tony somewhere. And then let's do the same against LazyDB. And we can see LazyDB right now is running at around 40%.
All right.
So that one seems to be happy right now.
Okay, so you're not running any queries against it. It's just transactions, and the S0 can keep up.
Yeah, whatever I'm running, it seems to be keeping up.
All right. Now, if I had a VM running a SQL Server or running a SQL Server on a box and I'm in this situation, I have to go upgrade my machine.
Correct.
Move stuff.
Correct.
Right. So what can we do here, though?
Correct. So if we look now at one thing more I wanted to mention, though, is you can see BusyDB is busy, LazyDB is not. LazyDB is running at almost 100% memory utilization.
I see.
It's worth pointing out that that's not bad, right?
Yeah.
Because
it's a database, it caches the data, so you want to use the memory as much as you can.
Exactly. Now, it was running at 100%, and the I/O percent, the read I/O percent was high, then you may need more memory.
Right, because now you know you're not able to cache it because you're doing all the I/Os and you're running out of both.
Exactly. And we're very happy about this percentage thing because it really simplifies performance tuning.
Right.
You just know that if you hit 100%, whatever that means for the particular price tier you're in, it means you have exhausted whatever resources you have.
So what you're saying is when the DTU hits 100%, it could be because one of those dimensions is hitting 100% or multiple of them.
Correct.
You could be out of I/O, you could be out of log throughput, or both.
Exactly. And through this view, as well as in the portal, you can see exactly which resource you're hitting.
So when I'm at 80% DTU utilization, I know I need more DTUs. I can actually go and see that I'm at 80% because the CPU is pegged at 80%.
Correct.
Okay.
So now let's look at what we could do about this. So clearly we don't need to do anything about lazy, right? Because
it's
lazy,
happy.
It seems to be happy. But this one, if it's at 99.9, that seems to be busy. So if we go back to the portal and I've opened BusyDB here, let's go and just say I want to change the pricing tier of BusyDB. And here you can see I can easily change it even up to, for example, a P4 with 500 DTUs. And you can see I'm currently an S0 with 10 DTUs.
Right.
So why don't we say let's upgrade to an S3 at 100 DTUs.
Okay, so that's like 10 times bigger.
Correct.
So you get 10 times more resources, 10 times more CPU.
Correct.
Okay, and that's it? You just go to the portal and you change the pricing tier?
Correct. And now this is all happening online. So now I don't need to think about, for example, taking my VM down, reconfiguring, restarting things. I just change the pricing tier.
So is the workload still running against it?
We will see. It seems to be running.
Okay. So as far as the users of this database are concerned, who are doing their transactions and who are doing their queries, they're continuing to work while this process is going on.
Correct.
Okay.
So let's see if I actually clicked it. So.
All right.
Maybe I didn't click it.
All right. So now this is the real one.
Let's hope. It worked.
There we go.
It was all because Tony.
Right. So we all know that this is a live demo, because if you don't make any mistakes, then it's not a real live demo.
But we rehearsed. No, never mind. Yeah.
All right.
Correct.
All right. How long is this going to take, Tobias?
Well, it can take a couple of minutes. It all depends on what's going on right now in the cloud.
But again, I mean, it could take a few minutes, but I don't care because my workload's still running. Exactly. Except I want it to be fast enough so that my users get happy sooner.
Yeah, and that's also why it can take a couple of minutes, is because we are moving the live workload over to another.
That's right. So we're being we're basically trying not to be disruptive of the workload while we're moving it.
Correct.
How does this move thing work in the first place?
Well, the move thing basically allocates a new instance or a new database somewhere in our cluster. It could be on the same machine as this one, could be on some completely other machine, and starts replicating the data to this other machine, and then at some point just points your connections against the new machine.
Got it.
So let's see how the BusyDB is doing. And yes, it's been upgraded now to an S3 with 100 DTUs versus the S0 with 10 DTUs.
All right, and what's happening with the transactions?
Well, let's see what the workload is doing here. So I'm in BusyDB here, and yeah, it's at now 96, 97%.
All right, so it's basically dropped down, but it's using 10 times more resources and pushing 10 times more transactions through.
Correct.
All right. So that's a pretty good estimate on your part and needing the S3 there.
Yeah, well, it's all by accident.
Yes, I'm sure you practiced this pretty well. So we were able to upgrade the database while the users are continuing to use the database, putting transactions and doing their queries. The database got upgraded. Now we're getting more transactions through, so more throughput. with the 10x higher DTU, 10x higher resources. Now, if you wanted to get more out, you could upgrade to a P1, I suppose?
Correct. And just to be clear here, it's not only about throughput. So a query that took 10 seconds before could finish in 1 second now because it has.
That's right, because it has more resources to finish. And if you are a frugal type and you need to balance budget versus user experience, you could have downgraded to an S2 and have the users wait a little longer, a little less throughput, but it'll be a lot cheaper.
Yeah, correct.
Yeah. So that worked out pretty well. So what else do you have for us?
Well, so let's take a look back into the portal here. So we also have this elastic pool concept, and that's really very useful. It's basically being able to take a number of databases and say, hey, let's have these share resources. It's very similar concept to a server. Now, a server is always limited to a single machine. And once you run out of resources on that one, well, you have to get a different server. And you also then in your application or yourself, you'll have to think about, well, where do I place my database? Do I put it on server A or do I put it on server B?
Right. So you have to, if you were doing servers, you'd have to do load balancing between the servers. You have to move stuff around. If you're using a pool, the databases are just in a pool. They can move around, and there's no work to be done on the application side. No changing connection strings and so on. They can move in and out of the pool freely.
Correct.
While online.
Correct. And so this is very much the old way, if you will, of using servers or just regular VMs. Is very much an imperative way of thinking. You tell it where it is and so on. Whereas this is much more declarative.
Got it. Now, since you're an expert and you managed to so perfectly fit your workload in an S3 at 97, you get your money's worth out of that. But then that other database was running at 40%, even though it was an S0, it wasn't using all of the resources. And imagine if you had hundreds of these databases, it's not likely that you're going to be able to so perfectly figure out how much resources and what size each database needs to be, whether it needs to be an S0, 1, 2, or 3 at different times of day.
Well, I'm not so sure. It's likely, it depends on who. I could, you could not.
Okay, so for those who don't want to spend all of their time figuring out exactly how much resources each one of their databases needs, they can put them in a pool and figure it out in aggregate.
Yeah, and the important thing there is obviously that they may need these resources, but not at the same time.
Got it. So database A could be spiking and needs 50 DTUs because for whatever reason, some customer is doing a report, while database B is not doing anything. So it all averages out.
Yeah, correct.
Okay, so you have a demo?
Yeah, let's click at my elastic pool that I created here. And you can see here that it's 200 DTU elastic pool that I chose. And it starts for standard pools at 100 DTU, so I could have picked a smaller one. This is just for simplicity. You can also say which databases are currently in the pool, and there's 0 databases in the pool right now.
Okay, so it's an empty pool. We have 200 DTUs in the pool. That's the policy set for the pool. And then, are there any other policies that are applicable to databases that you can set in the pool?
Yes. So the important thing is you can also specify a min and a max setting for databases in the pool.
All right. So the max would help me prevent bully databases from impacting other neighboring databases?
Yeah, just prevent databases from using more resources than you would like them to use.
All right. So if I have a customer and I think this is the level of experience that they're paying for, I can cap them at that level to ensure that they get what they need, but not more.
Well, that's to make sure that they don't get more. You have the other policy, which is the min DTU, which is to make sure that the pool always saves and those min DTUs for that database.
So nobody's going to get starved.
Exactly.
Got it. All right.
So let's take a look. As you can see here, we have 0 databases in this elastic pool. So I'll just click databases here, and we can say add database, and we can basically check the BusyDB and the LazyDB and hit select.
Now, in real life, you would have hundreds of databases here, not just 2.
Correct.
Yeah.
Correct. Or you could have 3.
A few. Yeah.
4, maybe. Could be 36.
Whatever works for your density needs for the DTU level that you have.
Exactly.
Because you're not paying for the databases anymore. you're paying for the pool.
Exactly.
Correct? So you're paying for the 200 DTU pool, and whether you have 5 databases in there or 8 databases or 10 databases, your average price per database depends on basically the density and the size of the pool that you have.
It's the cost of the pool divided by the number of databases. That's the average cost per database. But it doesn't matter, right? It's all just priced for the pool.
All right. So how long does it take to move a bunch of databases into a pool? Is it an online operation, I assume?
Yeah, it's exactly the same as upgrading or downgrading a database. And actually what happens on the back end, there's no difference.
Got it.
So right now what's happening is these are being put into the same pool. Given that the pool is small, they'll be operating over one machine in this case.
Okay, so before one of them was a S0 and the other one was an S3, which meant that they had certain amount of limitations and size resources and so on. So what happens to those settings when a database moves? A standard S0 moves to a pool. So this is a standard pool, I'm assuming, because that's the limits. So does it shed its 0s and 3s and 2s and just becomes a regular standard database with what happens here?
Exactly. It's now just part of the pool, and it takes on whatever limitations the pool comes with, whatever you have specified in your policies, such as max DTU, min DTU, and so on.
Got it. So it's no longer an S0 in a pool, it's an S database in a pool, and it inherits the policy settings of the pool.
Exactly.
And what happens if I'm not happy with the pool for a certain database and I want to move it out? What happens then?
Well, it's just the reverse. So you can say, okay, particular database 36, I want to move out of the pool and make it a P11 or an S0.
All right, excellent.
So we have one Elastic database in the pool, and apparently it's busy, has been added to the pool, and LazyDB is still
working on it. All right, so it takes some time for the databases to move. If you go move hundreds of databases, you should expect that it's going to take some time for the database to move, because the move process is being as least disruptive to the workload as possible. So it's trickling things in without having to impact the primary workload, which continues to run.
Correct.
Yeah. All right, so that's a pretty good deal.
Yeah, it's not
so
bad.
Is the busy database now really busy, or is it running at the same level?
Yeah, and so now it's running at a less of a level, right? Because it now has 200 DTUs.
Right. And so if it becomes less busy, then other databases can also use the DTUs. All right, excellent. Well, that was a pretty good demo, and thanks a lot. And thank you for watching our Azure SQL Database performance and scale demo.
Thank you, everyone.